Thank you all for coming out. Appreciate it. And hopefully it's going to be a great OpenSearch-Con for you. I am John Handler. I'm a Senior Principal Solutions Architect with AWS. I've been doing search for about 20 plus years now. And through all of the search technologies that AWS offers, as well working with the OpenSearch project. Today I'm going to talk a little bit of theory and a little bit of practice. I want to introduce the opensearch-ml-quickstart, which is an open source project I built with other contributors that helps you get started with code examples for most of the vector-related workloads in OpenSearch. But before we get into that, language is really the core of what we're dealing with, right? Whether we're talking about lexical search, where we're taking words and we're matching words, or we're talking about semantic search, where we use models that pull out meaning to match on a different level, it's all about bringing a particular query to a particular set of data in order to retrieve something that is the right thing, right? So very abstractly, we're matching user words to search documents, right? And similarity is kind of the proxy for meaning, right? So we have various measures of similarity, formerly BM25, currently a number of different methods and ways that we can evaluate the similarity of a query to a particular document and bring back the results. So I've talked with a lot of people who are coming from either a search world where they're already doing BM25 or just entering the fray, as it were. And one of the common themes is they want an easy button, right? They want to actually get to the right results, but the mindset is often like, oh, okay, I'm just going to throw an LLM at it, or I'm going to throw an embedding model at it, and it's going to do the right thing. And so what we try to talk with people about is starting with lexical, doing the right lexical things, then bringing in a semantic component as one additional tool that can help get better results. And now we all know the whole world is kind of going agentic, or maybe we don't know. The whole world is kind of going towards agents, which do a kind of different thing. And it can be confusing in this landscape to try to figure out, well, what is the right tool to apply for this particular thing? So I thought I'd spend just a couple of minutes talking a little bit about these different tools and sort of giving a little use, don't use, right? So for lexical search, as we say, we match query words to documents and we use BM25, plus a lot of additional machine learning technology can come into play that makes our results correct. It's not good at abstract queries. So if I want to know what are some comfortable pants, it's going to do okay, but only to the extent that I built a catalog of products that includes the word comfortable pants in the pants that I'm talking about. It can't actually get at that abstract notion of comfortable without somebody writing down the word comfortable, right? But it's really good for free text analysis and fast searching. And it's really good for specific queries, as we'll see in a second. So for semantic search uses models to construct high-dimensional vectors representing language, right? So again, we're still doing word-to-word. With semantic, what we're able to do is abstract away from individual words to something that's a little bit more abstract, for lack of a better word. So semantic search is really not good at very specific queries. Like if I'm talking about a brass half-inch NPT male to 3/8" female bushing, and I know that's exactly what I want, semantic search is the wrong tool for this. Because semantic search is trying to abstract some meaning. I don't mean anything except that specific thing. And so I should use lexical search and matching. But it's good for matching based on conceptual information. So what comprises comfortable is something that an embedding model can pull out of a piece of text. The word comfortable may never appear there, but the the embedding model will pull that word, that comfort concept out. And of course, semantic search is good for multiple modalities, different languages. There's a lot of stuff you can do that goes across kind of use cases. The world is coming down to hybrid because we have these two kind of polarities. On the abstraction scale, we have lexical and semantic, and really the idea with hybrid is to combine lexical and semantic to get best of both worlds for the matches. If you're doing some kind of iterative querying, right, hybrid can be a part of that, but hybrid is not the answer for, I want to run multiple queries because I'm doing some research about the genes I want to buy, and hybrid is going to find some genes, but it's not the iterative thing, right? But it is good for most search type use cases, and it maintains a relationship, a stronger relationship between the words that people type in a query box and the products that, or whatever, that is returned as search results. We're seeing a lot of conversational, probably everybody heard of RAG, right? So conversational extends the context, actually, into the conversation, right? So I can now use things like indexicals. I can say this or that, or I don't want that, or you know, I'm a man, don't show me woman's genes, or what have you, right? So don't use it, again, for very concrete, specific things. I want to buy the blah, blah, blah bushing. Not a good use. But it is good for researchy kind of use cases, where you have a more extended conversation that's like, okay, you showed me these genes, but they're too dark. Show me some lighter genes, right? And then you're able, through RAG, to take that conversational context and say, okay, these are not the right ones, I'm looking for this. And finally, with agentic, you know, agents use LLMs to select tools. They provide information to a final LLM that can summarize results. They're not really good for latency, right? So the agentic kind of workflow is a more researchy use case where you're not very, very concerned about matching in 10 milliseconds. Really, it's about an interactive multi-tool chain that is going to produce the best answer. And it's good for the reasoning and decision-making use cases. It's good for abstracting information retrieval from the specific use, right? So by employing different tools and different strategies, you can actually expand out into the space of available information to bring in something that's relevant. So just a quick summary on a few dimensions: lexical, semantic, hybrid, conversational, agentic. If you're looking for low latency, high throughput, lexical, semantic, hybrid, those are going to give you your low latency, high throughput kind of results. If you have very specific queries, lexical, and to some extent, hybrid. If you have really abstract queries, semantic, hybrid, maybe conversational, maybe agentic. If you're doing researchy kind of use cases, conversational and agentic, right? So let's talk about something more concrete. How do I actually implement this stuff with OpenSearch? Who's familiar OpenSearch neural plugin? So most folks. So within OpenSearch, the neural plugin, through the ML Commons plugin, provides you the ability to connect to and work with external models and internal models to do the kind of AI-powered work that you want to do. The main way you use it is in ingest and search. You define a pipeline for your index that defines a processor chain that can apply different tools. Within OpenSearch and the ingest processors that are available, one of those is text embedding. The text embedding processor then is able to engage through the neural plugin with a model like Amazon Bedrock or Cohere or OpenAI, et cetera, et cetera. On the query side, you have a similar pipeline that you can define, a search pipeline, a number of different tools in there. I'm calling out the ML inference processor. What that does is that's going to take a query and send it off to a model for encoding, and then be able to run that query as a vector query. So these are the main kind of interaction points as you're working with external models, internal models, and for ingest and for search. I'm going to give you just a code example. In your index mapping for the ingest pipeline, you'll define a default pipeline. In this case, I'm calling it multimodal pipeline. I have a mapping that includes a vector embedding, and then 2 fields, the image description and the image binary. And then when I want to ingest, I put ingest with the pipeline. I create the pipeline by saying multimodal pipeline. You'll see I have my processors, text, image, embedding. I include a model ID. Model ID is the way OpenSearch refers to these external models. And then I have my field mapping that says I want to go text, the vector should go in image description, and image should go in the image binary. On the search side, I put a pipeline. This is called hybrid pipeline. This is for hybrid search. I have a phase result processor. What this is going to do, it's going to normalize scores and blend them together. So I have a normalization processor with a normalization and a combination technique. However I'm doing the search, I define a pipeline that's like that one. And then for queries, I query with the search pipeline equals X. And that, in this case, is a hybrid query. It matches the text red shirt, and it runs a neural query. Neural query generates the embedding and does a vector search, right? Hybrid queries, you can have 5 of those. They don't have to be one vector and one text. Actually, the hybrid query type in OpenSearch is very capable of running multiple BM25 queries and blending, doing a lot of different stuff. So as I mentioned, OpenSearch provides the neural plugin. As a distributed architecture, you deploy nodes of different types. Typically, you'll have data nodes. Coordinator nodes are kind of a maybe, and cluster manager nodes. Data nodes hold data, respond to indexing requests and search requests. And you can also have ML nodes, where the ML functions specifically run. So if you're thinking about deploying and scaling, you may want to look at ML nodes as possible. Within that, then, the ML node has the connector framework well, not the ML node. OpenSearch has the connector framework that lets you connect to various models. Just a quick example of a connector. In this case, this is a SageMaker text embedding connector. SageMaker is an AWS service. I provide some AWS credentials and a region and a service name. And then the body of the interaction with the LLM is provided through the actions that I put into this connector. So I'm going to define this connector, which defines the connection to the model. Then within OpenSearch, I'm going to define a model. A model is an abstraction that has an ID. I use my model ID everywhere to refer to this particular model via this particular connector. And the connector itself also has an ID. So when you use models with OpenSearch, this is the machinery that you have to deploy to be able to connect to and use these external models. With OpenSearch 3.0, we released deployment templates, so workflow templates. How many of you know that OpenSearch has a workflow engine in it? 1 person. 2 people, 3 people. So the workflow engine enables executions of workflows. And with 3.0, we now have workflow templates that provide different capabilities to make it easier to use these AI-powered solutions. So we have deployment templates that automate for you the connector and the model, creation of the connector and the model that enables you to talk to that external model. This is, on the right, is an example of the workflow template invocation. In this case, I'm just doing create connector. I'm giving a role ARN and a region. Because I'm connecting to SageMaker, I need AWS credentials. We also have semantic search templates. These provide a text embedding and pipeline and an index. Neural sparse, if you want to engage with a sparse model, If you want to engage with a sparse model, this will bring a local model, an ingest pipeline, and an index together for you. We have multimodal search with a text-image embedding pipeline, auto-defined for you in an index. We have a hybrid search with an ingest pipeline, an index, and a search pipeline. And we have a conversational template that provides a chat model connector, a pipeline, and a retrieval-augmented generation processor. So all of these capabilities now come out of the box with OpenSearch, making it easy for you to connect and use in OpenSearch. How many people know that OpenSearch has an agent framework? Oh, more people than the workflow templates. Right, so with the agent framework, OpenSearch provides different ways for you to build agents that go and execute tasks on your behalf. So we have a flow agent that runs a particular tool set in a particular order. Oh, sorry, and there's an example over here. This is a conversational agent with an LLM connector. You'll notice the model ID, again, how we refer to that external model, with a prompt, as well as some additional parameters. And you'll see in this case, we've defined a number of tools for this conversational agent. So the conversational agent flow agent runs tools in order, maintaining conversational context. So you have a flow agent that's in order and a conversational flow agent that's in order. Then you have a conversational agent where the LLM uses the tool descriptions to sequence the tool applications and provides the conversational context as well. Finally, you have a plan, execute, reflect agent where the LLM reasons on the tools, and it's for long exploratory processes. So, is anybody super confused right at the moment? Yeah, okay. Because there are a lot of different parts and pieces, and you have to understand how to deploy them and in what sequence to deploy them. And when you're deploying them, there's a whole monitoring where there's a task that's creating a model, and you have to know the model is ready to use. There's a lot of steps. You have to create a connector. There's a model group, which provides security on top of models. You have to register a model. You have to deploy a model. You have to create an ingest pipeline. You have to ingest data. You have to create a search pipeline. And then finally, you can query, right? You have to ingest your data too. So these are the steps. There we go. And it's all repeated code. It's all super error prone. The state of the documentation right now is to provide you basically curl examples. There's not a clear, sort of end-to-end implementation of how to do this stuff. And so I have been working with, as I said, another contributor, Yuya from our China team, on the opensearch-ml-quickstart. This is an end-to-end example or set of examples that automates the entire deployment and access and query for these AI use cases. I'll have the thing later. So in the quick start, maybe a little small, but you can see we have examples here that include dense exact search, dense HNSW search, sparse search, hybrid search, lexical search, a conversational search, a conversational agent, and the various examples of the workflow templates. So all of these end-to-end, deploy everything, load a data set, and let you start using those queries. The quick start itself has a model abstraction, so it handles not only a self-managed deployment, local deployment, as well as a remote deployment for Amazon OpenSearch Service or any remote OpenSearch. It also has a connector abstraction that makes it easy to deal with models with two different flavors. We have embedding models and LLMs, large language models. So those abstractions, again, make it simpler to work with it in code. One of the pain points if you're using IAM and connecting to something is building out IAM roles. And the connector framework includes a whole suite of tools that goes and deploys the roles that you need for you, or uses ones that you've already created. So again, makes it simpler in terms of using AWS services. And you just configure the use cases, right? So you tell my host type is Amazon OpenSearch Service, my model type is embedding, my model host is Bedrock, and then the framework can go and create all of the pieces that you need to use it. The examples use the Amazon product Q&A data set. This is a data set of 4 million-ish user questions about products. It includes the answer, the question, and the answer, and some product information. So this is an example document that we have for the PQA data set. You'll see again the question text, 5/8 and pretty thin. Should I go for a small or medium? Category, t-shirts, a bunch of stuff. The chunk there includes the description. The answer, I'm 5'8" also. Usually wear women's medium. I order small and it's fitting, right? So these are the kind of data that we have. We have product data, question and answer data. The framework throws in the gender, user longitude, user latitude, the name, age, and product rating. It's all faked, but that gives the possibility of doing some work with that additional stuff. So I would say if you want to work with the Amazon PQA data set, actually the classes in here do a good job of formatting and reading that data and sending it to OpenSearch. So we're going to run through a couple of demos. The first one is lexical search. Everybody cross your fingers. So let me go here. What am I doing? I am going over here. All right. All right, and so just looking through what we're doing here. So it has an abstraction over OpenSearch as well that provides you a client that is capable of setting up all of the various pieces of KNN and the index and the mapping and all of that stuff. So the client connects to OpenSearch. It adds cluster settings that you need to enable communication with OpenSearch. It is then going to create the index. We're just outputting the mapping here. This corresponds exactly to the set of fields. It's kind of what you would expect. Because it's lexical search, we're not adding any vector in here yet. It then would load the data. I set no load because the semantic stuff actually is pretty slow. So I got my data set loaded up. I can run a query that is comfortable jeans. And we get the answers. Is this too tiny for you all? Everybody can see? Can you see in the back? Some shaking heads. Let me make it a little bigger. All right, we'll make it a tiny bit bigger. So we get skinny jeans. You'll see we have comfortable. We have slim fit jeans. Somewhere in here is hopefully comfortable. No, we just get a lot of jeans here. Oh, here's comfortable. And then we have stylish fashion 6 pocket style denim blue jeans. So looking quickly at the code. And again, if you can't see it in the back, please let me know. The main function, we have our PQA reader here. This class, again, does a really good job of being able to pull in categories and questions. There's a lot of parameters that you can use to sort of limit or control the data set that you're bringing in. We have some config at the top. So on the command line, I can set a number of categories. It'll read those categories in. I can set a number of documents. I can choose to delete indexes. I can change the bulk size that it's using to send to OpenSearch. There is an index creation that is a part of the client that handles the creation of the index. There is a data loading helper as well that just uses the PQA data set reads the file, sends those off to OpenSearch. We have a command line interface, kind of handy. It's a little interactive loop. That's the thing I'm typing at. So I wanted to show you that one because that's the simpler example compared to the semantic search one. So let's look over that one now. Let me scroll back up. So as I said, we can, by configuration, we can set, my host in this case is Amazon OpenSearch Service. My model host is Bedrock. My index name I could set. Embedding type, dense embedding. I can use dense, I can use sparse. And then I can name my pipeline. This config manager controls all of the configuration that I use. It reads it, puts it in a flat file, and then vends it out depending on the set of configuration that I'm passing in. If I want to use OpenSearch Service in Bedrock, the configuration manager can generate the configuration that the code base needs to go connect to that. So I provide my host type, provider, my provider, and my model type. Configuration manager just says, here's your configuration, right? We add some additional configuration using KNN, get the field map for the pipeline. Again, this is configurable. You can say which field should map from source to destination for embedding generation. I pick my embedding type, categories, delete existing index, and then I build a client on top of that. This one is a little bit more complex because I wanted to not do loading. So if I'm not loading, I still need to get the model. So in this case, I get a model name that is a standard model name. It'll go reuse a model if it exists. I get a model config, and then I get a model, right? So the get model provides me with the ML model that I need to communicate. If I'm not doing that, then I'm going to run the workflows. Okay, so the workflow templates, again, enable me easily to automate some of the tasks that we talked about, creating connectors, creating models, creating pipelines. The first one I'm going to use is the Bedrock Titan embedding model deploy. This one goes and deploys a connector and a model to connect to Bedrock. It's fairly straightforward. I'm not going to go into that code. And then if I'm going to, I need to add credentials, and then I get a model ID that I can use. I'm then going to execute the semantic search workflow. First, I set up all these parameters that tell the template how to run, and I execute the workflow to create the semantic search, the search pipeline, as well as the, create the search pipeline. And then I can load my data, and I can run my interactive search loop. So let's go ahead and do that one. Bust out of this. Nope. It's over here. And in this case, we'll see it's going to put out the connector so we can see what is the connector that it ended up creating. In this case, we're using the invoke with bringing in stuff from the body, and I'm able to query. So if I do the same comfortable so hopefully we get some better results. So comfort, Denon Outfitters, men's classic, 5-pocket slim fit, blah, blah, blah. So this is retrieved based on chunking with the product description and the Q&A data. And I'm pulling now stuff that may or may not have comfortable. So this is comfort. Modulo stemming, I might or might not have matched that with a lexical search. Here I have high-rise skinny jeans. These don't mention comfort at all. And so you can see here where, again, the concept of comfort is something that the embedding model was able to pull out and provide me with this search result, even though it doesn't actually say comfortable. Similar, vibrant women's high-waist, stretchy, ripped jeans. High-waist stretch, these are juniors. So again, the semantic search is providing me with that wider context that enables me to pull these. And the last one I wanted to look at was the agentic search. So if we look at our conversational agent, what we're doing is, again, through configuration, we're using a local OpenSearch deployment. We are using the conversational agent knowledge base as our index name. It's dense embedding, and we have a pipeline here. Again, I set up my Q&A reader. I add a bunch of additional config. I get a model. That's going to create the whole connector model frame objects. And then I'm going to create my index. So again, handle index creation. I'm going to set up for KNN. So again, the client itself includes a lot of code that sets up for you the index. It sets up for you based on the model dimensions, which you set by configuration with endpoints and et cetera, et cetera. I'm going to load my data. And then I am going to create an LLM model. So create the LLM model is very similar. I set a provider type, a host type, a model type of LLM. Under the covers, the connector framework handles all of the doing that. I create my agent, and then I'm going to run my interactive agent loop. So let's look for a second at the agent to get an example of that. That should be up here. And I'm going to also, again, slip a little bit into some theory here. So the agent itself, I think one of the interesting things with agents is that, up to the present, we've had declarative control flow and data processing. With agents now, it's become much less clear where is the locus of control flow. It's now left us. It's gone off into these agents, which are reasoning and picking tools and applying them. So, and I don't think the world has figured it out. Like, where do you draw the line? Like, is it in the agent prompt? Is it in the tool, the agent prompt, the tool description? Where is it that we're actually defining the flow of control, right? The agent is just picking stuff, right? So this is my attempt at being clever with writing a prompt, right? You're a helpful assistant that can answer questions about products. Knowledge base contains user questions and answers with one search document per user question. The search document also contains product information, like item name, product, all of that. You have tools that search based on matching the user question to the question in the search result, as well as lexical and semantic search against the product information. Because the knowledge base is organized by user question, you may not get a broad range of products, so keep that in mind and maybe run multiple passes. Then also evaluate whether this looks like a specific question about some product or could be a question about products, and do a question retrieval, and then try to apply the answers to the question to the query. Or it could be a much broader question just about products, in which case you should do semantic and lexical search and try that. So say what you did. Did you actually approach it as a broad question or a specific question? And then if there are search results but they're not relevant, please don't tell me anything. Okay? So this is our agent prompt. Within that, we also get some tools. So I have a get products tool, semantic, lexical, Q&A lexical, get categories tool, and a couple of others, list index and index mapping. All of those are broken out here. And just to give you a little bit of flavor, let me look at the Q&A tool. So the catalog contains user questions and answers about the products in the catalog. This tool uses lexical search to find questions users have asked about particular products, right? The idea being, if I'm asking, are these jeans good for, a man? I don't know. Are they too dark? What have you? Then the agent can look at the questions instead of looking at the products, right? So this is a way of merging in two different kinds of data for an agent to be able to provide an answer. In this case, this is the query. We add additional attributes. So this is the sort of conversational agent tool or example. And yep. So we have copious output here. I won't go into great detail. It defines, this is the agent definition. Here's the connector that it comes up with. Here's the mapping. Within the mapping, you'll notice somewhere is the KNN field, which I think is called chunk embedding. Yeah. So this is a Bedrock. Nope, this is SageMaker. This is a paraphrase Hugging Face model. So if I, again, ask my trusty comfortable everyday pants, oh, I haven't been saying everyday. Now, here's the fun part about using agents. Remember I said it was very researchy and kind of not really, for very low latency? So now we have the agent is off doing things. We kind of don't know what exactly the agent is doing yet. This is going to take about 30 seconds, so I'm just going to sort of vamp up here and try to entertain you while the agent goes and thinks. So oh, that's good. That timed out nicely. So we actually have some answer here, and we can see the trace of what the agent did. The agent says, I'll help you find comfortable everyday pants. Let me search for options that match what you're looking for. With the category search tool, comfortable everyday pants. Unfortunately, there's a bug. The search results are not printing, but there are search results there. Now it picks the semantic search tool for comfortable everyday pants, and it gets harem pants for men and women, Aladdin pants, 100% cotton, blah, blah, blah. And it gets these 5 search results. It then checks the lexical search, comfortable everyday pants. It gets this casual cotton high waist bootleg a bunch of times. And then check if there are specific questions. So it runs the question search tool. Again, the search results are not printing. Sorry about that. I'll go fix that after the conference. So based on its search results, it provides me with several options. It does pick the Sorica and Dickies men's everyday durable cargo pants, fit couture, unique women's quick dry cargo travel pants, harem pants. User feedback indicates comfort is a key feature that people look for in everyday pants, right? So comfortable everyday pants, it kind of pulled that out. So it was able to generate this set of results. And I wanted to show you, if I just say, I work in an office that is very casual. So now, let me actually run it. So if you imagine a lexical search engine where I just say, I work in an office that's very casual, right? Without having a conversational context, there's no way that the search tool can provide me with additional information. One of the nice things about this conversational agent, and also that's true of RAG, is it maintains this ability to look beyond the individual question. And if I just make a bold statement like, I work in an office that's very casual, it can actually tie that into the conversation and know that I'm still talking about pants, right? And so we'll see it did a little bit different kind of searching. Okay, so it goes to the category search tool, the semantic search tool, and it's coming up with this high quality, lightweight fabric, polyester. I don't even see a name on that one. A lot of, here's the Dickies yoga pants it comes up with. You'll notice also it changes the question that it's sending to the semantic search, right? It actually tries different questions. So in this case, casual office attire comfortable. Gets a bunch of stuff from the lexical search tool. And then let's look for some casual office tops as well, which I didn't ask for. That's interesting. So it throws tops in there. Let's try comfortable shoes. I didn't do any of this. I just said I work in an office, it's very casual, right? So it's coming up with these strategies and reasoning about the results that are coming out. It thinks I might want shoes. Okay, let's look at shoes, right? and also comfortable flats and loafers. Final results gives me some summarization in terms of here are some pants, here's for men, for women, here are some tops, here's some footwear, right? So again, the agent, the control flow is like going to the agent now. I didn't tell it to do any of that. I have one more example that I'll run. And I'm a man who generally wears jeans, but looking for other options. And now I have to vamp again. And so again, I will say, I didn't tell it what to do. I just said, hey, I'm a man, and I like casual, I like to wear jeans, right? Hopefully prompting the LLM to find me some jeans, but sorry, not jeans, because I asked for other options, right? All right, well, that wasn't too slow. That was great. So what did we come up with? Chinos and khakis, dress pants and slacks, elastic waist pants, cargo pants, athletic jogger pants. If we look through the trace here, it actually, at the end, it's already got men's chino, khakis, dress pants, slacks, alternatives to jeans, right? So this is all out there. It is the opensearch-ml-quickstart. You can run all of these examples with a little bit of configuration, and you can also potentially reuse the code. And my quick commercial is, there's lots more to do with the opensearch-ml-quickstart. So if folks want to contribute, I would really welcome additional contributions. So we went through our demos, and I'll just wrap quickly by saying that chat, semantic search provide additional ways to find what you're looking for. And OpenSearch provides tools to create the embeddings, and the ML Quickstart helps you avoid repetitive coding tasks, make mistakes, et cetera. And hopefully you can reuse this in your own systems. Like, hopefully these classes will help you get started with OpenSearch for ML. I'll also mention that we just published a book. It's available. During the course of the conference and until September 15th, it's a 20% discount. I know I'm shilling for myself, but there it is. Proud of the book. I think it came out really nicely. Hopefully it has some good stuff in it for you. And that's what I got. Thank you.